Good morning, everyone. Just wanted to start the presentation now. This is the presentation for encrypted media extensions. So if you're looking for Biology 101, you're in the wrong room. So we're going to talk a little bit about a platform content decryption modules for the EME spec. And I'm also going to go into a quick primer on writing your own CDM, and because there's not a lot of documentation out there on that. So I want to, you can get the slides, after this presentation, take them back with you so you can have something as a reference. Okay, so who's this guy up here talking? My name is Matt Snoby. I work for Cisco as a technical lead. Currently, I'm in the LHG home group as an assignee. Been working on set-top boxes for way too long. But it started out working for NOG revision, integrating conditional access, moved on to PowerKey, and then more recently, a lot of digital rights management, including Intertrust, Verimatrix, some Play-Ready HLS, and VideoGuard. Also, like I said earlier, Apple HLS, GStreamer plugins, and pipelines. If after you go home, you're looking at this presentation, you have some questions, here are a couple email addresses, you can get a hold of me. It's my LinkedIn page. Seems like a cool thing to put up there. Okay, this is what we're going to talk about today. If you have a question, interrupt me. If I don't know the answer, I'll just tell you I don't know it, and we can email back and forth, and I'll try to find out the answer for you. But we're going to talk about what is EME, what is CDMs, why we chose to do this work in the Chromium browser. We'll talk about how DRMs interact with CDMs. We're going to talk about using a personal computer x86-based CDM on an embedded target with just a basic cross-compile. We're going to talk about the ClearKey CDM that the Linaro home group implemented. I'm going to give you some tips on how to start your own CDM if you want. I'm going to tell you how to create some test content because it's not just block encrypted. It's actually, you got to know the programs to use. I'll give you a couple undocumented tricks, and then what's next for our implementation for our member boards. All right, here's the obligatory terminology slide. So, EME, encrypted media extensions. This is that new web spec from the W3C for having a standardized interface between encrypted content display, basically. It's basically so a web browser can provide an API to control playback of protected media content. There's the usual DRM, everyone here knows it's a type of technology that, it controls the playback of digital content, typically through decryption. Now, you'll also hear a new term called key systems when you're reading the EME spec. This is just a fancy term, a generic term for a decryption mechanism for a DRM system. And then finally, we have here the content decryption module. This is the piece of software that runs on your actual target hardware, whether it's PC. It can typically not come with the browser, but this is the guy that does all the real work, that knows how to talk to the DRM system. Okay, so let me dig into what a CDM is a little bit more. So typically, it provides the functionality such as decryption. Think of Play-Ready, think of Widevine. So key systems can be a full-blown DRM system, right? You can be Widevine, like I said earlier, or it can even be a much simpler system, like the EME spec says for a ClearKey, where the key that's used to encrypt the content is well known, but it still shows the functionality of the CDM. It shows the functionality of the EME implementation. So like I said, it can be a full-blown commercial DRM system or even a ClearKey. And here in the Linaro home group, we implemented a clear key solution because we're not trying to implement another DRM here. We're trying to kick off a platform for others to use for accelerating their development on target hardware. So the CDM should be customized for the platform. So examples of this can be, an off-the-shelf personal computer x86 Widevine CDM, or, you can have a version of PlayReady that's been compiled for ARM that has hardware-accelerated decryption compiled in libraries linked. So if you go in your Ubuntu Linux box right now, and you've got Chromium installed, you're going to have a Widevine shared library that you can use to play back EME content using Widevine. And that is delivered when you install Chromium. But it doesn't have to be. You can install a CDM out of band whether the browser is installed or not. So it's not part, it doesn't necessarily have to be a part of the browser install. The CDM is going to run out of browser process space. This is important, one, for security, but also if something happens in the CDM, it's not going to take down your browser. It's not going to take down your browser tab. All right, why did we choose Chromium for this? Well, it's open source. We can put it on just about any target hardware we want. They're also a leader in EME development. If you look at the W3C spec that's going through, these guys are leading the charge. The spec, the Chromium source, it's constantly moving in regards to the EME and CDM interfaces. Anytime, because the spec is not, it's in draft. So they're always constantly updating. I would also say why we chose Chromium is because of support. There's not a lot of documentation out here. There's a lot of theory websites. There's a lot of, this is how it'll work. But there's not a lot of, here's an implementation and here's how you do it. And I personally emailed with quite a few Google engineers when I was working on this project, and they were very responsive. They were excited that more people were taking an interest in this, and solved quite a few of my problems when I was just getting started. And then, of course, like I said earlier, it's open source, so you can see the code and figure out why your code is crashing or how something is supposed to be implemented. Okay. So DRM systems in the past always have some sort of proprietary interface. And what a CDM really does try to do is it tries to standardize that interface. So if you think about pairing and authorization, with the EMA spec, that's all done through the JavaScript HTML5 app, right? That's not the job of the key system. So in the past, when you had a traditional DRM, it was either provisioned at factory, you had pairing in the factory, or you did some sort of out in the field, root of trust pairing. But that's handled differently in the EME spec. Another large difference here is, you have PlayReady, you have Widevine or Verimatrix, and all the communication is handled between that process and your secure server, right? And that's not how it works in EME. Everything goes through the browser. Every bit of communication is encrypted and is passed through the user agent. So everything is in band, right? There's no out-of-band communication between your CDM and your secure gateway or your secure server. APIs, everything is session-based with CDM, and if you have a traditional DRM, it's however they decided to implement it. And then finally, in traditional DRM systems, you couldn't just reset your pairing data. Whereas the EME spec really does want to have the user to have some control. They don't want the user to be tracked. So they want the user to have the ability to reset the pairing, sort of like deleting the cookies in your browser. Okay, so you've got Widevine. There's a Widevine CDM out there. And you've got an ARM target board. Why not just use that on your target board? Just go to the Widevine guys and say, hey, can you cross-compile this for me? Well, embedded CPUs don't have the horsepower to really do multi-stream decryption and still provide a good, smooth user interface at the same time. You're missing out on all that money you spent on your SOC for accelerated hardware decryption. So there's no hardware block decryptor. And also, when you're on your embedded target, you have the ability to protect your buffers after decryption. On a PC, there's no hardware to do that. But as an example, here with ARM, you've got Trust Zone so that you can protect that buffer after it's been decrypted so that the only thing that can see that decrypted buffer is hardware. Okay, so let's talk a little bit about the ClearKey CDM that we implemented here in the Linaro home group. So why did we do it, right? There's already an external ClearKey that comes with Chromium. Why bother taking the time to write our own? So in all honesty, it was a lot of a learning experience. Like the only way you can really understand the code is to get in there and do it yourself, right? You want to know the ins and outs. You want to speak with authority on the topic. And because the spec is changing so much, you don't want to go into the code, make a bunch of changes, try to upstream them, and then find out that A, it's already been done, or B, it's been completely thrown away because the spec has changed. So we wanted to spend some time, figure out how to write a CDM, and then use it as a launch pad for future development work. Meaning we want to use it to pass around in open source so that people can use it to see how you protect buffers with ARM Trust Zone, as an example. All right. So here's the stuff that when you go home and you want to play around with this stuff, how do you get started? Well, you pull the tip of Chromium and you wait an hour.
If you're lucky.
If you're lucky. And you build Chromium, debug. I know the previous presentation said that here's another hour you're waiting, at least. So that's how you get started. You just build Chromium. Now, the external ClearKey that comes with Chromium does not get built by default. So after you get done building Chrome, you build this target of this shared library called the ClearKey Cdm Adapter. All right. Well, now that you've got your CDM, how are you going to control it? You need a HTML5 page. You need some JavaScript, right? Well, the Chromium guys have done this work for you. They've already written their test app, HTML5 app, located under your source tree under the media test data directory. Specifically, under the specific HTML5 page is EME_player, and then all the JavaScript source files are under the directory EME_player_JavaScript. So what I did was I just copied all this after I made my modifications for my own ClearKey, copied it to my own web browser so I could run and test. So here's how you start up Chrome to playback content with the external ClearKey. I enable logging I register my Pepper plugin, which is the Cdm adapter, because this is running out of process. And then I just have it automatically load the HTML5 page. This is the HTML5 page that gets loaded. 4 easy steps. I give it the URL I want to play. It's a local host file. And this content comes with Chromium. It's 2 seconds. It's small. So I select which key system I want to use. I just want to use the external clear key. It's a drop-down list. And I'm going to use the prefixed EME spec draft API. There is an unprefix that is evolving on an almost daily basis, but for doing CDM testing and development, using the prefixed APIs is sufficient. Press play and you get video. And I'll demonstrate this a bit later. So, all right, you've watched your 2-second of test video, but now you want some real content to play back. Well, here I'm going to use FFmpeg on a PC to convert an MP4 file to a WebM file. So I'm converting, basically, an H.264 with AAC in it to a WebM container that's VP9 and Vorbis as the audio. And this is actually a fairly high-quality convert I'm doing here. It's actually a fairly large video. Now, you've got an unencrypted WebM file, which doesn't seem very useful if you're going to test CDM. So now you have to go track down this program called WebM_crypt, which you can find here. And this is the program that basically knows how to open up a WebM container, which is basically, it's an MKV container with some tweaks. Think fragmented MP4. And so what this program will do is it will block encrypt the elementary streams, but still leaving the container unencrypted. Here's the command line you use. It's very simple. The base secret file is very simple. It's a 16-byte file that holds your binary key. And the key that I used was the same key that Chromium used for their external clear key. So the video that I am encrypting here can be played back with the Linaro clear key and or the external clear key that comes with Chromium. All right, let's talk about some of the undocumented features of the CDM interface in Chromium. So it's a session-based API, and there are some methods in here. One is decrypt, and another one is decrypt and decode frame. So if you have your CDM, the play button's been pressed, the code comes down, you've decrypted it. Now, you can set up the CDM to do 2 things. You can either decrypt the content and give the content back to Chromium to hardware accelerate and decode to the screen, or you set it up to do decrypt and decode frame, where you decrypt the content, you now have a decrypted frame, and you can do whatever you want with it. You can send it to GStreamer. You can protect it with a trust zone, and then the trust zone, you shuttle the buffer over to your hardware decoder. So how do you switch into this mode? There, in the CDM initialization, there is a call for video decoder initialize. And the only way you know to tell Chromium to do the display is you just return an error message to the decoder. Initialization. This isn't documented anywhere. This is where you have to dig into the code. So if you want to have Chromium deal with all the video playback after you've decrypted it, you just return a K-session error in the initialize call. Otherwise, in your decoder initialization, you set up your GStreamer pipelines, and you are responsible for decoding the frames after you decrypt them. One other little secret. The Cdm Adapter Code is something you have to link into every single one of your CDMs with Chromium. This takes care of all the housekeeping of running out of process in Chromium. I did not link this in at first, and was one of the first problems I ran into, because as soon as you started your CDM up, there was a seg fault, and there was no backtrace. Doesn't matter if you were running debug, there was no backtrace. So it's a little hint to save you some time. All right, so what's next? We're going to implement this on a member board, more than likely a B2120, and we're going to implement a hardware block decryptor for hardware acceleration decryption, and we're going to secure the buffers with trust zone. After that, we're going to send the buffers to GStreamer for decode for a full secure pipeline. So that's all I have for display. I have a demonstration I can show, but I want to know if there's any questions at this point.
Can you talk about the CDMI a little bit?
Sure. So Microsoft and another German company have come up with an interface called the CDMI interface. And basically what they're trying to do is standardize the CDM interface for the browser. So whether you have Firefox, Mozilla, or Chromium, the CDM interface is not going to be the same. And so they've made an attempt to create an interface. And they've actually abstracted away the browser, the CDM interface, and the media engine. I've looked at the code. I haven't run the code. But for every hardware platform I've seen, we're going to run Chromium on it. And so that extra layer of software didn't seem like the first place to start.
Yeah, but Matt, that's also for PlayReady. That CDMI wrapper is for all the browsers to support PlayReady, right? So that's kind of where that interface is coming from. They wanted to enable PlayReady for Firefox, etc. So I think there is a PlayReady specific definition in that.
Sure. Once I see the code, I can comment on that, but I have not seen the PlayReady CDMI interface code.
But that code, that CDMI was defined by Microsoft and then implemented by Fraunhofer Focus, and then FF went and did an open CDM interface on that. So my understanding, and you can correct me when you see it, but it was to essentially allow those other browsers to have access to PlayReady through that mechanism, is the way I saw it.
Sure. And like I said, once I see the code, I can make a comment on it, but I have not seen the code.
I have a question.
Yes.
So, I mean, like if I just look at a CDM, right, it's an independent platform. It's a software that's running on the platform. Now, how does it look to the browser or any other application? Does it look like a libcdm or something like that, or how does it look like? I mean,
It is a shared library that you register with Chromium at boot up.
And is it set up in a way that, like, PlayReady DRM can plug into this CDM, or like the reason I ask is, like, say for example you have PlayReady DRM and a wideband DRM, can they, like, in runtime provide a plugin or something like that, like how you would provide a V4L2 plugin or some other plugin to GStreamer? Can it be plugged into the libcdm?
That's actually all in implementation detail. If you have multiple CDMs, how it's set up in Chromium is you have a CDM that's just the session API that is a glue layer to the actual DRM. And so you'd have a PlayReady CDM shared library file or a wideband CDM shared library file.
Yeah, that's right. So it's a CDM per key system.
Yes, it is a CDM per key system,
Right.
yes.
And then we're also working to look at how we can put a layer to try to accommodate multiple DRMs through some abstraction layer. Ultimately, we'd like to have.
Did that answer your question, Bish?
So, I mean, just to clarify, so the vision is going to be that, say for example, my hardware, it just has a PlayReady DRM implemented in the CDM. Can I, like, during runtime load like a wideband DRM and link it dynamically to the CDM so that when I load my JavaScript, I can query what kind of CDMs are supported on this particular platform.
Yes, inside Chromium, there is a list of what key systems are supported. And at boot up, Chromium can look at well-known areas in the file system for which shared libraries are there and which shared libraries go with which key system.
So from a JavaScript application, you can query that if it does that.
From a JavaScript application, I can't comment because I don't know. I haven't done that. But I know in the C code inside Chromium that that's how it's registered. So let me give a demonstration of video playback using the demo app that comes with Chromium. So this is just the command line I used earlier. This is the default video that is encrypted WebM file that comes with Chromium. I'm going to select the Linaro external clear key. I have my prefixed EME. And I press play. And there I have 2 seconds worth of video of a bear walking around, which is incredibly not exciting at all. But it shows that, hey, it works. So let's play a better video. I'm doing this over my shoulder. Same thing, Linaro external clear key, prefixed EME.
Matt,
Yes.
is the path to the renderer also encrypted, or is that the CDM implementation dependent? I mean, like, is there some point at which it gets in the clear, and at least the point at which it gets in the clear, is that like all the way through to the renderer, or are there clear buffers somewhere before it gets to the renderer?
So that is a complete implementation detail. You would hope that when you implement this on an embedded target, that that's going to be secured all the way to the renderer.
So Chromium, okay, I get it. But Chromium has the hooks to make sure that we can secure it all the way to the renderer.
Well, Chromium just says decrypt and decode frame and let me know when that frame's been decoded.
Okay. Because I know sometimes Google has these like, like sometimes they take care of they manage the renderer paths. At least in the stage fright case, I think they have, they have their own renderer or something like that. And I'm not sure how that, if we can secure it all the way to that renderer.
Right, so for example, in our full punching mechanism, the buffers are not fed back to Chromium, so in that case,
Okay.
that's not an
So it's
issue.
complete.
And also in other cases, we have the DNA buff demo with
Which is
the
also
OpenGL,
secure.
where we actually can fully protect the buffer if it goes through the DSP, if it goes through the GPU up to the display.
Okay.
So more questions?
I have another question. The stream that's actually going to the stream that's getting decrypted, is there any constraint in terms of you said it's like session based and all that, right? So sometimes you have streams where it's possible that maybe the entire stream is encrypted. I guess including the container. Is that
Yeah,
the
that's
case?
not in the spec. The EME spec says the container has to be
The container has to be in the clear.
It has to be in the clear because it only supports WebM and fragmented MP4 container right now.
Okay, so there is a limitation there.
Yeah, you're not going to just have block encryption.
Okay.
So one of the challenges that I heard that might happen is, WebM is a container, the content is encrypted, but are there limitations in the decoders where, there are some hardware-based decoders that don't need any metadata to be fed into the decoder, but are there challenges where some of the data has to be fed into the decoder, saying that giving some header information in the decrypted block?
So it's only the elementary streams that are block encrypted. So any information that you need from the container will be in the clear. So PID values, codec type, that will be in the clear. That's it.
Just a comment, that's one of the criticisms of the EME spec right now for fragmented before people who still do HLS want transport stream-based solution, and there has to be accommodations for HLS.
Is there a CDM for DTCP IP based decryption?
No, there is not.
Is any plans for anything you heard about anything in that direction?
I have not heard anything, but the draft spec webpage gets constantly updated. I mean, this is a very fast-moving spec. I mean, something like that may have been proposed, and I could have missed it very easily.
Okay.
But that's a different type, that's a link layer encryption, right, which is different than a DRM system. It's not exactly the same thing.
Well, I mean, it is session-based, and it is, like when you say, I mean, it's streaming content, right, that's coming in to your box, and, you know, it's encrypted, and the container is in the clear, so I don't see why we cannot decrypt it using a CDM. I mean, there's no reason why it cannot. There's no technological
I haven't seen,
Yeah, I guess there is.
Technically, you could.
Technically, you could, yeah.
But I haven't seen that yet.
Solution is not.
Okay, well, I was hoping for harder questions, but I guess if you're going to let me off that easily, I'll be here the rest of the week. Be happy to discuss this with anyone. Be happy to show you the code. In the show notes that's up on the website, I have a white paper written on some much more in depth on the Chromium CDM interface. So if you're interested in that, please take a look. Thank you.